Hello and welcome to the first video of this channel. In this video, we're going to talk about ZPAQ, its features, and benchmark its performance. ZPAQ is a tool developed by Matt Mahoney. He released the initial version on February 2009 and maintained it until 2016 by releasing version 7.15. It took the place of PAQ and its variations, which Matt had also created. ZPAQ uses deduplication and several algorithms depending on the data type and the selected compression level. ZPAQ has 6 levels for compression ranging from 0 to 5. Unfortunately, ZPAQ doesn't have an error correction mechanism. It checks for SHA-1 hashes upon decompression and shows a warning in case of an error, but cannot fix it. Before we head down to charts, let's talk about our method and how we do our tests. For our dataset, we are using a collection of files comprising audio, pictures, and videos, each containing 3 types of formats. As an example, for videos, we have MP4, MKV, and WebM. We also added some HTML files grabbed from popular websites, some fonts, and code repositories like C#, Python, and Java. For some added challenges, there are a few Photoshop files and plenty of resource files for DaVinci Resolve. As a cherry on top, we dropped some executables and installer files from 3 major operating systems, Mac, Windows, and Linux. To ensure fairness and avoid favoring any algorithm, each category of a file is approximately the same size, which is around 105 megabytes. The test bench is an AMD 3400G paired with 16 GB of DDR4 RAM at 3200 MHz. And for the storage, we have a 1TB 8 Legend 700. As for the OS, we are running Windows 11 Home Edition 22H2. The results are the average of 3 runs with a 30-second gap between each run to let the PC return to idle temperature. For our testing, we use the latest 64-bit version of ZPAQ, which is 7.15. As we said earlier, ZPAQ has 6 levels of compression. You can also define block size ranging from 0 to 11. We are going to benchmark every combination possible. There are other advanced options that you can adjust to get better results and fine-tune the algorithm. But we are letting ZPAQ itself determine them for us this time. At level 0, we see a 4.6% size reduction with block size set to 0. Increasing the block size, however, seems to not affect the space saving. Rather, it just increases the processing time. And at block size set to 11, it's taking double the time, yet delivering no improvement in compression. Decompression speed yet seems unaffected and roughly around 70 to 75 megabytes per second, at least until block size 11, which it decreases to 58 megabytes per second. We wanted to decide which level is the most efficient among others, and by that, we mean which one reduces the size more per each second of operation. For that, we made this chart. We divided the space-saving percentage by the average compression time of each level. Here, we see by increasing the block size, the efficiency score drops gradually, and almost half at block size 11. Things change at level 1. We see good starts at 19.8% space saving and a meaningful increase by raising the block size up to 26%. It all seems good until you look at the compression time chart. Till block size 8 seems reasonable, a bit less than a minute, but beyond that, it's just too much for small gains. Still, the decompression speed is largely unaffected until block size 10 and 11, but compression speed plummets from 100 megabytes per second to only 6 megabytes per second, and that costs efficiency score at 0.09. It's the least efficient in level 1. With block size set to 3, we see a very acceptable score at 1.14, and this leads in efficiency till now. At level 2, we see an increase in space saving at both the minimum and maximum block size, starting at 20% and ending at 26.9%. Still, the massive increase in compression time can't justify the small gains enough, and waiting for 5 minutes just to get 1.5% more size reduction seems uninteresting for us. The combination of small gains and large time additions means worse efficiency score, and as you can see, we can't even touch the efficiency score of 1. Level 3 starts space saving at 23.6% with block size set to 0 and reaches up to 29% at block size 11. Here, compression time begins at around 1 minute and reaches as high as half an hour for block size 11. With processing speeds halving compared to level 2, it is expected to deliver a more inferior efficiency score than level 2. Now, let's check out the last two levels, level 4 and level 5, which are set to deliver the best compression. Level 4 with block size 11 can deliver a good 30% space saving. Compression time starts at 2 minutes here, and for block size 11, it takes about 35 minutes to complete. At under 1 megabytes per second, it's very slow, and efficiency score can't even pass the 0.2 mark. And the last level, level 5, we begin the chart with 26% space saving. We were getting better and better results until we hit block size 10 and 11. The memory requirements for these levels were so enormous that our 16GB kit just couldn't handle it, and they failed to finish. And even if they didn't, we would be looking at over 3 to 5 hours of processing time for each pass. Processing speeds at best hovering at 1 megabytes per second and near 400 kilobytes per second at block size 9. So there is nothing to say about efficiency here. Nothing. Completely inefficient compared to other levels. Now let's check out the best performers on each section on each level and compare them against each other to select our two winners, the most powerful and the most efficient. The top performer in space saving is level 4 with block size 11 at 30.15%. We can guess that level 5 at block size 11 can beat it, but we couldn't run it for now, not with 16GB of RAM. In the efficiency score chart, we picked the best in each level, and here are the results. Level 1 at block size 3 crowns the efficiency chart at 1.14, and although level 0 was performing faster, the results in space saving were such low that it's even less efficient than level 3 and only better than level 4 and 5. Level 2 also shows a good result here, but for the best compression with the least amount of time, ZPAQ at level 1 with block size set to 3 is a definite choice. Thank you for watching this video. Hit like if you liked this video. Tell us your thoughts in the comments down below, and we will see you next time.